Hello everybody, I am Taylor Peterson.
And I'm Hunter Ensign.
We are here to show you our project that we created for MIS5400. We will start by just showing you some of the data that we used. So we have this cars.csv file, and what it is, it just contains data from a bunch of different cars that were manufactured between the 1970s and 1980s. It just contains key characteristics such as each car's miles per gallon, the number of cylinders, horsepower, weight, etc. And then just for reference to later, something we'll discuss, we have this row here at the bottom that contains some extra data, just more columns than what it should. And that's just, we're going to discuss later how we accounted for rows such as that later. So moving forward, kind of the environment in which we chose to create our project was Jupyter Notebooks. So we just have this main notebook here that we'll just take you through here. And we'll kind of just go through and talk about each of the different libraries that we use and how we implemented them. So let me clear the output here so we can see it all. Cool. So we'll just load in our libraries here. And then before we get into too much of it, I just wanted to kind of go through the path that the data is following here to hopefully kind of help those who are watching this video follow along. So as previously stated, our data is starting out just in that raw CSV file. What we're going to do is we're going to first load that data into a pandas data frame. With that data frame, we're going to load that into a persistent database using the SQLite library. And then we're going to query from that SQLite data frame back into a pandas data from that SQLite database back into a pandas data frame where we can then analyze our data and find different information about it. One might think, why are you going back and forth between pandas to your database? The reason for that is just because pandas is something that Hunter and I were more familiar with. It has different functions that we were able to utilize to cleanse our data, to do things such as account for those bad lines. And so it was just easier for us to first load into pandas before going into the database. But we'll talk more about that as we go through. So we're just going to go through each one of these cells here. The first thing we're going to do is create a database to use for this. So as you can see, there's no file in here right now ending in .db. We're just going to run this cell, and we'll jump back over here, and we can see, hopefully here in a second, that it creates this database.db file for us to use. From there, we're going to create a table within that database. So we set a cursor within the database and then just execute this SQL query that's going to create our table. We do this just so that we can kind of determine data types and things such as that. From there, we're going to create a blank data frame, give it some column names, and then load the data from our cars.csv file into that blank data frame. And then this line is just going to give us a display of it. So we'll run that. And as we can see, we ended up with 398 rows and 10 columns within this database. Within this data frame, pandas data frame. And then you also notice this output that we got here. That was just these certain criteria that we gave to our read CSV function that we told it to skip over those bad lines. So if you remember at the beginning, we talked about how it had those extra, that extra data in those columns there. That's why we used pandas here, is just to account for lines such as that so that we don't end up with messy data within our data frame. So now we've got a blank table within our database and a data frame that contains all the data that we want. We're just going to merge those into one. This toSQL function is just going to send all the data from our cars data frame into our database. So we'll run that. And then this is just a query we're going to execute against our database to show that that data successfully made it in. So it's not super pretty, but we can see that we now have persistent data in that database.db file, so that if we come back later with more cars we want to add on, or if we come back later, we don't have to recreate all of our different data frames. We just have that persistent data so that we can query against it quickly and easily. From there, we're just going to pull from there just back into a pandas data frame so that we can analyze it and run different queries against it to find useful information. So I'm just going to run this quick select star from our cars. This is the pandas.readSQL function. So it's just going to use Q as the query. And this is the connection to our database. So we'll run that. As we can see, we have the same data we had here in the database, just put into a pandas data frame. So now Hunter's just going to talk about some of the queries that we ran against this data and some of the information that we found.
Thanks, Taylor. So now that Taylor has described how we got our data, make sure it was persistent in a local database file within this folder, we then identified a bunch of different queries that we wanted to run on the data to try and gain some significant insights. So the first thing that we thought we'd take a look at is how average miles per gallon relates to number of cylinders. And so we defined Q as a query, select average miles per gallon in cylinders from cars, and then group by cylinders. And so once we ran that, we also used matplotlib to output a little graph to help us visualize the data. And so you can see here, it's kind of to be expected. There's a negative correlation between number of cylinders and miles per gallon, with 3 being kind of an outlier. But one reason we thought maybe this could be is there are some diesel trucks that obviously do not get very good gas mileage, but that have just 3 massive cylinders in their engine. But as you can see, 4 cylinders is like the average number of cylinders for a small car, and thus it gets like the highest miles per gallon. And then you move down to like a V8 engine, obviously not great gas mileage. And so our presumption of what this data would look like is kind of verified through this query and visualization through matplotlib. And so then moving on, we thought an interesting thing to look at would be if miles per gallon improved over time, if car manufacturers were able to start making cars that had a better miles per gallon. And so we, again, identified Q as a SQL query that just selected the average miles per gallon and then the model year from the data frame cars, and then we grouped it by the model year. And so you can see, again, through the graph, through matplotlib, in the years 70 up to 82, there was a significant increase of miles per gallon in relating to as the year went by, and again, grouping by model year. And so again, another one of our presumptions was kind of validated through this. Another query we wrote was just to compare average horsepower to the origin country to see if maybe American car manufacturers made less efficient cars, maybe they were faster and less efficient, or if what it looked like. And so we obviously grouped it in from Europe, Japan, and USA, and we were able to see that, oh, that's right as well. It looks like USA was pumping out higher horsepower cars, and maybe Europe was making less powerful cars and Japan was making less powerful cars. So maybe the American public had a little bit more of a need for speed than our neighbors across the ocean. And so lastly, we wanted to just do a quick look and see what were the lightest and heaviest cars within the data. And so we found that it was a Pontiac Safari, and it weighed, I think that's in pounds, so 5,140 pounds. And that's this car at the bottom, and it just kind of looks like a boat. It's really heavy looking, big car. And then the other one is a Datsun 1200. And as you can see, that's the top picture. That weighs only 1,600 pounds, and it looks like a small car. It looks like it's got pizza cutters for wheels. And so we're able to kind of look at the heaviest and the lightest cars within our data set.
Yep. So we're really happy with how this project turned out, just because we thought it was really cool. A lot of the time when analyzing data, you utilize a lot of different applications. You might use one program to cleanse or scrape your data and then cleanse your data and then maybe move it into somewhere else to query it and find things and then go elsewhere to visualize it. But we thought it was really cool that through this, utilizing these different libraries in Python, we were able to do everything just here in this one environment. And everything from, cleansing our data to putting it into a persistent database to being able to analyze and visualize it as well. And so, yeah, we hope you enjoyed our presentation. We had a lot of fun making it, and thanks for watching.
Thanks. Bye.